Why does the same Ethereum transfer sometimes cost different? One address sends ETH to another, a simple operation. Yet the fee can differ. To understand why, we need to look inside how Ethereum executes transactions. We've talked before about smart contracts as rule-based programs. They define what is allowed and what is not. But rules still need to be executed, and execution has a cost. That cost is called gas. Gas is often described as a transaction fee, but that is only the final outcome. At its core, gas measures computation. Every action requires work: reading data, updating storage, executing logic, calling other contracts. Gas tracks that work. A useful analogy is electricity. A machine performs work. An electricity meter measures energy consumed. Gas works similarly. Smart contracts define what should happen. Ethereum executes those instructions. Computation is measured in gas during execution. Let's see how this works in a real transaction. Before sending, your wallet shows an estimate. It is not the final fee, just a simulation. You set 3 limits: gas limit, max fee, and priority fee. These are boundaries, not the final price. Once sent, gas burns step by step. The network sets the price per unit. Each block has a base fee, which changes with demand. You can add an optional priority fee. It increases your total cost, but gives you higher priority. If gas runs out, execution stops and reverts. If enough gas, it completes. After execution, the final fee is calculated. It depends on how much gas was used and the price at that moment. You never pay a fixed fee up front. You set limits. The final cost comes after. A simple if transfer uses 21,000 gas. More complex contract interactions use more. But gas is not money. Gas measures how much computation is used. GUE measures the price per unit of the computation. GUE is a denomination of Ether. 1 GUE equals 1/1000th of an ETH. It's the standard unit used for transaction fees on Ethereum. And transaction fees combine both. Gas measures computation. GUE measures the price per unit. The fee is what you pay in ETH. Computation on Ethereum must be bounded. Without limits, contracts could consume excessive resources. Gas prevents this. Execution proceeds only while gas is available, but gas also helps price-limited block space. And this explains why fees vary. Consider a simple if transfer. The amount of gas used may stay similar, but during heavy demand, the fee may rise sharply. Many transactions compete for limited block space. The work did not change. Demand changed. Ethereum reflects this through a base fee that adjusts with demand and optional priority fees for faster inclusion. Gas measures the work. Demand determines the price of that work. But price is not the only reason gas exists. It also protects the network. Gas protects 3 things. It keeps computation bounded, it makes abuse expensive, and it helps allocate limited block space. Without gas, contracts could consume excessive resources. Network operation could degrade. Execution would become far less predictable. Gas helps make decentralized computation workable. It is not an extra tax layered on top of Ethereum. It is part of how Ethereum functions. In practice, most users do not need to manage gas manually. For simple transfers, wallet defaults usually work well. If fees look high, network congestion is usually the reason. Waiting can help. If you want to check network activity, tools like Etherscan Gas Tracker can help. For contract interactions, lowering gas limits often backfires, and setting a very low gas price can leave a transaction stuck. If a transaction runs out of gas, execution reverts, but the fee is still paid. For most transactions, wallet defaults are usually enough. Gas is how Ethereum measures, limits, and prices computation, and that is what makes decentralized execution possible.